I have another code sample, which I'm going to use to demonstrate how collections leverage equality comparers. Recall that I introduced a food item struct earlier in the course. It's just like the food class, it contains a name and a food group, but this time it's a struct, which means you can't derive from it, and which will simplify things a bit for us when we write our equality comparer. To give this example a realistic context, I'll imagine that we need to store a set of food items, and we want to make sure that each food item can only go in the set once. I'll swap to this program's main method. I declare a list of food items and add various items to it. Apple, then pear, then pineapple, then another apple. And there's a for each loop with a console.writeLine statement that shows what's in the list. Let's run that. That's not quite what we want, because you can see that all 4 items are there. Apple has been added twice. The fix to that is to use a collection called a hash set. I'll change this declaration from list of food item to hash set of food item. Hash set of T is a collection that has a useful feature that you can only add an item to it once. So I'll run the code again. Now you can see that apple is only in the collection once. That's because when hashset tries to add anything to its collection, it automatically detects if that object is already in the set, and so won't add it a second time. Now let's think a bit more carefully about how hashset can do this. The only way that hashset can tell if an item of type T is already in the collection is by testing whether it's equal to other instances in the collection. So our hash set of food item must somehow be leveraging the fact that food items know how to compare themselves for equality. And in fact, that is what's happening. We can see this if we put a breakpoint just before one of the add methods, and another one in food item's strongly typed equals method that we wrote earlier in the course. If we run the code again, but this time in the debugger, we're at the add method, so I'll step over that. And look, we've hit the food item equals method, even though we've not explicitly called it anywhere. The call stack shows the main method, then external code. You can't see what that is, but clearly it's hashset's add method. And then food item.equals. So clearly hashset is doing something inside its add method to invoke our equals method. Let's stop the code and remove the breakpoints. That's fine so far, but what happens if I make this second apple have a capital A in its name? Let's run the code again. And you can see apple is now in the hashset twice. The reason is, of course, that our equals method invokes the equality operator on the food name, and for strings that does ordinal, case-sensitive string comparisons. That's actually a reasonable thing to do. It's what string does out of the box, so it's what developers are likely to expect IEquatable implementations to do too. But it means our food item equals method will basically tell the hash set that apple in lowercase and apple with a capital A are different food items and not equal.